Hi everyone, my name is Sandeep and today we are going to solve a problem which is Domino and Tromino. So what is the problem? First we need to understand what is Domino and what is Tromino type. So Domino is nothing but you can see that we have a row and there are two columns here, and similarly we have a Tromino where we have two rows, we have two columns, but here you can see there is one cell is missed. So Domino looks like this and Tromino looks like this, and in this problem we are given a value n, an integer value n, and we need to find out that how many possible combinations are there to create a 2 cross n rectangle, you can say, or 2 cross n size of rectangle we can create. So here 2 is nothing but rows and n is nothing but the number of columns we need on that rectangle. But there are some other things that we need to understand before solving this problem, and that is, if you see this domino, we can use this domino in two different ways. The first is in the horizontal way, the another is in the vertical way. Similarly, this domino tile, it is in that format, but we can use it in the inverse format, and similarly we can use it in the L shape and a reverse L shape. So this is the very important thing before we solve this problem. And where here we have to find all the possible combinations for 2 cross n rectangles. Now here one important thing we need to understand: when we are going to create a rectangle of 2 cross n, we have to make sure that every cell in that rectangle is fully filled. It means there is no empty cells like that. So this is also important point that we need to understand before solving this problem. Now let's take an example and understand how basically we can solve it. So here you can see where we have n equal to 3, and in this case we basically need to create a 2 cross 3 rectangle. And you can see here that we have 5 different combinations that we can use. Here we use a vertical domino and two horizontal domino. Here we use three vertical domino. Here we use two horizontal domino and one is a vertical domino. And here we use two domino, and here we also use two domino of different shapes. And that's how we are able to get all the 5 possible combinations. Now, how we can solve this problem? Now, as you know, there is a all possible solution. When you're trying to solve a problem, there is a pattern we always need to find. And here, when we are trying to solve something which is all possible solutions or all possible combinations or maximum value or minimum value, so in that case, we basically used dynamic programming to solve this problem. Now, what is a dynamic programming? What dynamic programming says? Dynamic programming says we have a problem of size n, but we always give n minus 1 problem to solve recursion. So there is a recurrence relation, or you can simply say there is a n minus 1 problem which is always solved by someone, or recurrence relation, and we only need to understand how we can solve our nth problem. How we can solve our nth problem. Now let's understand what are the different cases that we may find where we need to fill the nth part of the tiling. Okay. So what are the different scenarios where we only have to think or look about how we can fill the last or nth part of the tiling? So here you can see this is the first scenario. Okay, this is the first scenario we have, where if you see this, okay, let me change the color. Okay, if you see this, here you can see that we have a rectangle, right? And in that case n minus 1 is already solved, and we can simply add one vertical domino and we are able to get a solution for this. Again, we have another situation where we need to add two horizontal dominoes, but here we are able to take up two spaces, but here we can also find a solution for the nth tiling too. Another situation is we may have this situation where we have a bottom cell missing. Here you can see we have a bottom cell missing and we can use a Tromino, and here we are able to find the nth tiling problem. Similarly, here we have a upper cell is missing and we can use this Tromino, and but we are able to find a solution for nth tiling. So here you can see in order to find solution for the nth tiling, like how we can fill the last tile of this problem, we have all these 4 patterns. So can I say like this: for making a rectangle, a full rectangle, right? For making a full rectangle of size n, what type of possible solutions we have? So we can use the following solution. The first is we basically use this n minus 1 solution. Okay, so for now I am using it fr, full rectangle is fr, which is n minus 1. Then here you can see for n minus 2, we take all the combinations of n minus 2, right? And then we can basically use this solution, but we can basically use all the n minus 2 combinations. Then here you can see this is something different pattern. This is the pattern where the bottom cell is missing. So for now we can say bottom cell missing. Okay, now bottom cell missing, and here we have n minus 1, right? Here we have n minus 1. we need to get all the combination for bottom cell missing for n minus 1, and similarly we have a top cell missing here, so top cell missing, and it is also n minus 1. Now here you can see, by using this combination we are able to solve the nth or the last tile in the rectangle. But here is one more thing, like at every position or at every ith position or every nth position, we are able to store this in the full react array, right? So we are able to get all the combinations for n minus 1. Okay, we are able to get all the possible solutions for n minus 2 because we are recording it in this array. But what about the bottom cell missing and the top cell missing? We need to find out, or we need to store somewhere, that at nth minus 1 position how many possible patterns we are able to find with a bottom cell missing, and then only, right? Because let's suppose at n minus 1 we have 10 different patterns with this bottom cell missing. So for all that patterns we can attach this tiling and we get 10 possible solution. So but somewhere we need to store about number of possible patterns such that it will make a bottom cell missing and for the top cell missing. So let's understand how we can find the bottom cell missing pattern. So the first thing, if you think about how we can find about the bottom cell missing, and in that case what you can see, that let's suppose if we have a tiling like that, right, where everything is full, everything is filled, no cell is empty, and if we use what we can say, this type of tiling. Okay, so if we use n minus 2 and this is n minus 1. Okay, so this is n minus 2 and I'm sorry, here small difference. So this is n minus 2, n minus 1, and this is n. So if we take a whole rectangle and we add a Tromino with this, and you can see that we get a bottom cell missing. So this is the first way. What is the another way of doing that? The another way of doing that, let's suppose if we have already a pattern like this. I'm sorry, I basically need to make this like this and then this. Okay, and if I add a horizontal tiling like this, horizontal domino, now you can see that we have a bottom cell missing. Okay, so in this case you can see that I have a top missing cell first, so it is n minus 1 and then it is n. So these are the two possible solutions we can say where we have bottom cell missing. So here bottom cell is missing and here bottom cell is missing. Here we use a rectangle, so we are saying full rectangle with n minus 2. If we have this, we are able to create the bottom cell missing. The another possible solution is we need a Tromino with a top cell missing, so we need a top cell missing and the size is n minus 1. So by calculating these two values, okay, we are able to get, for nth position we are able to get the total number of possible bottom cell missing patterns. Similarly, we will think about top cell missing. How many top cell missing pattern we are able to find? The first one is if we take this whole rectangle, right, and if we take this rectangle and if we put this type of Tromino here, right, now you can see that we have a top cell missing here, right? So you can see for nth position, one we can use n minus 1, right? This is n minus 1 and this is like this till there, and this is n, right? Sorry, n minus 2, then this is n minus 1 and this is n, the same as above actually. So here we need to 2. Okay? The another possible way is we basically use this, right, and if we add a horizontal domino like this, now you can see there is a missing one. Again, this is n minus 1 and this one is last one is nth, and here we use a bottom cell missing. Here we use a bottom cell missing, so which is bottom cell missing n minus 1. So at the end of the day, you can see for each position, for nth position, the first we will find the full rectangle, and in order to find the full rectangle for the nth position, right, we have this combination that we will use, right, and for the bottom cell missing and top cell missing, we can use, for bottom cell missing we can use this combination, and for this combination, and similarly for the top cell missing we can use this combination and this combination. And at the end of the day, when we are trying to solve all this possible combination at position of this nth value, we are able to get our solution. Now what is fr, what is bottom missing, and what is top missing? This is nothing but a array. Okay, this is nothing but a array that will store all possible combinations of pattern. To understand it more, let's see how we can code this. So everyone, we are trying to solve this problem. Okay, so here I'm using three different variables: full rectangle, top, and bottom rectangle. So here we have some base case. If n is 0, there is only one possible solution, and if n is 1, there is only one possible solution, because we need, at any point in this case, we need 2 cross n, so basically 2 rows we need, so we can use this domino for that, or 2 rows means uh, yeah, 2 dominoes we can use. Okay, and similarly, in order to solve the top rect missing or bottom rect missing, if n equal to 1, we basically have a 0 possible solution for that, and for n equal to 1, we have 0 possible solution. Now we will start ranging from 2 to n plus 1, so that for every position we will find out all the possible solution. For filling up the ith, or you can consider this case where we are going to solve a problem for the nth tiling. Here we have that same combination that we understand for I minus 1, I minus 2, for top missing I minus 1, and here again, this is something wrong. This is wrong actually. So we have a top missing I minus 1, and we have a bottom. So we have a bottom rectangle I minus 1, and then we have a top rectangle. For the top missing, we have this combination, and for the bottom missing, we have again this combination, which is I minus 2 and I minus 1. And the solution can be very large, so we need to modulo it by 1 billion 7, and we are doing this modulo, and here we go. Let's submit the solution, and obviously we will solve all the cases, and we are able to see that it is working fine. So I hope you like it. Thank you.